Howdy! Welcome to the Physics Festival. We're talking about the railgun today. It's a pretty neat demo, and I'll introduce you guys briefly to the physics of how it works. Essentially, forgive my crude drawing, we have two rails connected to this capacitor bank. And Nathan will talk a little bit more about what the heck the capacitor bank does. But what happens, the physics behind it is when you, this circuit is incomplete, but when you stick a conductor in between these two rails, the circuit will be complete, and the capacitors will just dump tons of charge into the circuit. Using these two laws, well, the Dawson's law and then, a formulation of the Lorentz force, you get this induced magnetic field that causes a force on the system to expand, right? But the rods can't expand out, so the only expansion that can happen within the circuit is the projectile, and that's how the projectile shoots out.
Howdy, so I'm Nathan, and so here is our railgun. Like Logan said, we have two rods that are parallel to each other. We have a air compressor pumped at 50 psi that shoots the projectile or initiates the projectile, and then in the circuitry, here's our capacitor bank that Logan mentioned. A capacitor bank is somewhat like a battery where it does store charge, but unlike a battery, a capacitor bank will discharge all the current at once, but a battery will take time for it to discharge.
Thanks, Nathan, for your explanation. It was excellent. This is the control panel for the railgun. It has a couple safety features built into it because it is one of the more dangerous demos at the festival. Essentially, to start it or start the charging process, it's plugged into the wall. To get the charge to the wall, you have to turn this key, and then there's this firing switch, and I'm going to turn that on. And right here you can see this is the voltage as it's climbing. We're at 70 volts right now. 100, 40, we're going to get it up to 250. 200, 250, and we're going to turn it off. So now it's stabilized at around 254 volts.
So we've stuck the projectile in here, and now we're gonna cover it up. I've been pumping up compressed air to get it to 50 psi, and now we're ready to fire this bad boy. 3, 2, 1.
Bullseye. All right, as you can see in that last shot, there were sparks in all these shots, but the last one got stuck. You can see what's been going on to the projectile. The sparks come from something called ablation, which is a big problem in making big railguns. Essentially, as a projectile is inserted into the circuit, it has the potential of spot welding to the sides of the rails. Yeah, but the railgun is a pretty cool demo. Actually, there are examples of people making bigger railguns. The Navy, for example, they've been working for the last 10, 20 years on building railguns for some of their ships. And I think a couple space agencies are working on building railguns for launching things into space. It's pretty cool technology. The biggest problems with these large railguns, though, like I said, is that the railguns are essentially just stripping themselves apart. I think the Navy railgun can only shoot 10 to 15 times before they have to get new rails in there. Another problem with using these big railguns is that they consume so much energy. Railguns are awesome though, so you won't find a better demo at the Physics Festival than this one.